welcome to Easy BTech. Today my topic is double integrals in polar form. Before that, please like, share, subscribe Easy BTech channel. So double integrals in polar form. So polar form means the form is like r is equal to f of theta model here. Then to evaluate double integrations in polar form, to evaluate integral theta 1 to theta 2 and r is equal to f1 of theta to f2 of theta f of r comma theta dr d theta. Okay students, so to evaluate this double integration in polar form, the same as usual procedure which we are followed in Cartesian form also. So that means if r limits are as a functions of theta and theta limits are constants, then at first you have to do the integration with respect to r at first and then integration with respect to theta. Then r limits are as a functions of theta, and theta limits are constants. Okay, then integration with respect to r at first, okay, and then integration with respect to theta. Okay, so suppose to evaluate integral r1 to r2 and theta is equal to f1 r2 f2 of r f of r comma theta and d theta dr. That means here theta limits are in terms of r and r limits are constants here. Then theta limits are in terms of r to f2 of r and r limits are in terms of r1 to r2. Then you have to do the integration with respect to theta at first, okay, and then with respect to r. Next integration is r here. Then constant integrations are second time integration. Variable integrations is first integration. Okay. So now the problem related to this topic. Evaluate integral 0 to pi and integral 0 to a into 1 plus cos theta r dr d theta. Okay, it is the question. So observe here in this question, the first limits are in terms of theta here. See here, it is the theta limits. That means so in the solution, so integral 0 to pi and integral 0 to a into 1 plus cos theta r. So these limits are in terms of theta here. That means the first limits are r limits and second limits are theta limits here. Then at first have to do the integration with respect to r at first and then have to do the integration with respect to theta. Second integration is theta. Then integral theta is equal to 0 to pi. So with respect to r integration, so r integration is r square by 2 within the limits 0 to a into 1 plus cos theta and again d theta. Then making 1 by 2 common, so theta to pi is the limits for theta here, 0 to pi. In the place of r, you substitute the upper limit, that is a into 1 plus cos theta and whole square into d theta. Okay, so now a into 1 plus cos theta whole square, then a square into 1 plus cos theta whole square here. is equal to 1 by 2 integral theta is equal to 0 to pi a square 1 plus cos theta whole square d theta. A square is also common, a square by 2 integral theta is equal to 0 to pi 1 plus cos theta whole square 1 plus cos theta whole square d theta. Now for this integration 1 plus cos theta whole square, we may apply a plus b whole square formula here to evaluate this one, or otherwise we know the formula, one formula here, that is 1 plus cos theta is 2 cos square theta by 2. Okay, 1 plus cos theta is 2 cos square theta by 2. So now I am applying that formula. So a square by 2 is equal to a square by 2 theta is equal to 0 to pi. Then 1 plus cos theta is 2 cos square theta by 2 and whole square into d theta. Then a square by 2, and here 2 square as a 4, then 4 is common here, and integral theta to pi, then cos power 4 theta by 2 d theta. Okay, then for the integration, to get the integration of this thing, we are using one substitution method here. Then put theta by 2 is equal to t, then theta is equal to 2t. Differentiating with respect to t here, then dt is equal to 2 into d theta is equal to 2 into dt. So limits, so when theta is equal to 0, then 0 by 2 is equal to t, then t limit is 0. So similarly, so when theta is equal to pi, so pi by 2 is the limit of t. So this is the upper limit value and this one is the lower limit value. So now substituting the limit here and doing the cancellation here, 2a square integral t is equal to 0 to pi by 2 cos power 4 theta by 2 is nothing but t here, then the value of d theta is here 2 dt, then 2 dt, then again 2 is common, already 2a square is there here, that is 4a square t is equal to 0 to pi by 2 cos power 4t dt. So we are having formula this one. So what is this formula? N minus 1 by even formula, even values formula here, because the power is even here. Then n minus 1 by n and n minus 3 by n minus 2 and so on, pi by 2 formula. N is 4 here, then 3 by 4 and again 1 by 2 and into pi by 2. Then 4 will be cancelled here. Then 3 pi a square by 4 is the answer of this question. 3 pi a square by 4. Coming to the next question. Same model. Double integral in polar form. Yeah, the second problem. Evaluate integral 0 to pi by 4 integral 0 to a sin theta r by root of a square minus r square dr d theta. Okay, so the solution. So it was given that 0 to pi by 4 and 0 to a sin theta r by root of a square minus r square dr d theta. Yeah, observe here students, the first limits are as functions of theta was given here, then the first limits are r limits and second limits are theta limits. Then at first you have to do the integration with respect to r at first and then have to do the integration with respect to theta here. Then for that purpose integration theta is equal to 0 to pi by 4. So I am doing here with multiplied with minus 2 and dividing with minus 2 here. A sin theta minus 2r by root of a square minus r square and dr and again d theta. So minus 2 as a doing the multiplication, the same thing here I am doing the division. If you are doing the cancellation of this minus 2 and this minus 2, problem will be remaining as it is, r by root of a square minus r square. So why here we are using this minus 2 multiplication means in integration we are having one formula, f dash x by root of f of x dx is equal to 2 root f of x. So the denominator function within the roots must and should be have the differentiation term in the numerator. Then see here a square minus r square is there, then a square differentiation is 0, then r square differentiation is minus 2r. Okay, but the question consisting only r, then we need to apply this formula, we need minus 2. That's why we are doing this multiplication with 2. Then integration theta is equal to 0 to pi by 4 minus 1 by 2. Now applying the formula 2 root f of x. 2 root f of x means a square minus r square within the limits 0 to a sin theta and again d theta. Okay, this 2 and 2 will be cancelled and minus as a common, integral theta is equal to 0 to pi by 4. So apply the upper limit at first. In the place of r we have to apply upper limit. So r a sin theta in the place of r, if r square is there then the value is a square sin square theta and minus, so the lower limit for r square a square minus 0 into d theta. Okay, minus integral 0 to pi by 4 theta limits, and here a square minus a square sin square theta. See here a square minus a square sin square theta. So a square is common, that is 1 minus sin square theta, a square cos square theta. Then within the root this value a square minus a square sin square theta, then a square cos square theta, that is a cos theta. So total value is here a cos theta and minus root a square, square and root will be cancelled. Then final answer is minus a for the lower term substitution value. So a cos theta minus a into d theta. So now a common here, minus a integral theta is equal to 0 to pi by 4 cos theta minus 1 because a is common here d theta. So now doing the integration. So integral theta is equal to 0 to pi by 4 cos theta d theta minus theta is equal to 0 to pi by 4 1 d theta. Okay, and minus c. Yeah, okay. Now the cos integration is sin theta within the limits 0 to pi by 4 and 1 integration is theta, that is 0 to pi by 4. Then minus a, then sin pi by 4 for lower limit 0 and minus pi by 4, that is minus a sin pi by 4 is 1 by root 2 minus pi by 4 is the answer of this question. The next topic is change of variables in double integrals. Change of variables in double integrals. Then transformation of coordinates. How we are changing from one variable coordinates to another variable coordinates. So let x is equal to f of u comma v and y is equal to g of u comma v be the relations between the old variables x comma y with the new variables u comma v of new coordinate system. So then double integral r of f of x comma y dx dy is equal to double integral r f of, so the function x is f of u comma v and y is g of u comma v and the value of dx dy is the Jacobian transformation of dx dy. It is equation 1 here. So where j is nothing but here Jacobian transformation, and it can be evaluated dou of x comma y by dou of u comma v. Okay, the next side heading, change of variable from Cartesian to polar form. Okay, change of variables here in double integration, the transformation of coordinates, students. If x is a function of u comma v and y is a function of y is a function of u comma b variables, then the relation between the old variables and the new variables will be, so x comma y are the old variables and u comma v is the new variable here. Then f of x comma y, substituting the new variables in the place of old variables, and dx dy is nothing but Jacobian transformation of dx dy. So how we can change Cartesian form to polar form here? Then Cartesian form means y is equal to f of x and polar form is r is equal to f of theta. So okay, so now I am writing the substitutions which we are using to change Cartesian form to polar form. Yeah, okay, so in this case we have x is equal to r cos theta and y is equal to r sin theta. Okay, students, and the Jacobian transformation j is equal to dou of x comma y by dou of r comma theta, determinant value dou x by dou r and dou x by dou theta, dou y by dou r, dou y by dou theta. So x and y values are there here. So if you are finding the corresponding differentiations here, you will get the values cos theta minus r sin theta and sin theta and r cos theta. Okay, students. So how you will get these 4 values? By doing the partial differentiating of x with respect to r and theta, and partial differentiating of y with respect to r and theta. Yeah, here determinant value r cos square theta and plus r sin square theta. So if r is common, then cos square theta plus sin square theta is equal to 1. Now substitute the Jacobian transformation value in equation 1, then you will get double integration r f of x comma y dx dy is double integration r f of x is here r cos theta and y is r sin theta, and dx dy is nothing but here r dr d theta. So these 3 substitutions we are using when we are changing Cartesian form to polar form. The 3 substitutions are x is equal to r cos theta and y is equal to r sin theta, and the value of dx dy is r dr d theta. Okay students. Okay, now the problems related to this topic. Yeah, I am writing the problem. The first question related to the topic. The first question: evaluate integral 0 to a and integral 0 to root of a square minus x square y into root of x square plus y square dx dy by transforming into polar coordinates. Okay students, it is our question, changing into the polar coordinates. Yeah, the solution. It was given that here, given integral 0 to a and integral 0 to root of a square minus x square y into root of x square plus y square dx dy. See here in the question, the first limits are as a functions of x here, then these limits are y limits and these limits are x limits. Then the region of integration is by using the limits only. Y is equal to 0 to y is equal to root of a square minus x square. Then if you are squaring on both sides, you will get y square is equal to a square minus x square. That means x square plus y square is equal to a square. Then similarly, so if you are writing the x limits, x is equal to 0 to x is equal to a. So now I am drawing the corresponding diagram using the given limits x and y. Then x square plus y square is equal to a square is a circle equation which is symmetrical about the 4 axis. Okay, this is x square plus y square is equal to a square. In the given question, so both lower limits are 0 here. That means the required region is in the first quadrant only. Okay students. Then here the point 0 comma 0, on x axis the value of y is 0 and the radius value is a here, and y axis the value of x is 0 here, then it is the required region here. Okay students. Yeah, now we have to change Cartesian form to polar form here. Okay, because the question is in Cartesian form. So how can you say that it is in Cartesian form? Because the question consisting x and y variable. Okay, then changing to polar coordinates, changing into polar form. So we know the substitutions here. Put x is equal to r cos theta. And next one, y is equal to r sin theta. And again, dx dy is equal to r dr d theta. These are the main three substitutions we are using to change Cartesian form to polar form. Yeah, okay. So now if you are changing the question in terms of r and theta, then we need the limits of r and theta also. So by using the given limits only, we have to find the r limit and theta limit here. So then when the x limit's lower limit was given here 0 and y lower limit is also given here, then we know the value of x here. X means here r cos theta is equal to 0. Then cos theta is equal to 0 and theta is equal to cos inverse 0. Cos inverse 0 is nothing but here theta is equal to pi by 2. Okay. So when you will get 0 in cos, that is the meaning of cos inverse 0. So then cos 0 1 and cos 0 is 1 only. Then cos 90 value is nothing but here 0. When you will get the 0 in cos is nothing but cos inverse 0. Okay. Then similarly y0. So y is here r sin theta is equal to 0 and sin theta is equal to 0. Theta is equal to sin inverse 0 and theta is equal to 0. So these are the theta limits here. So theta is equal to 0 to theta is equal to pi by 2. Okay, theta limits. Then to find the r limits here, then it was given that x square plus y square is equal to a square. Then x is nothing but r cos theta. X square is r square cos square theta. And y square is r square sin square theta is equal to a square. So if you are making r square common, cos square theta plus sin square theta is equal to a square, then r is equal to a is the one limit. Then this limit becomes as a upper limit here. So because the total required region is in the first quadrant only, then the lower limit of r is as 0 only. Okay. So I am writing the limits here. R limits are 0 to a and theta limits are 0 to pi by 2. Okay. And the question was given here. Question is y into root of x square plus y square. This is the integrand term. Then you have to change this integrand term in terms of r and theta. Okay, because here we are changing Cartesian form to polar form. Then the integrand function also have to change here. Then integral, I am writing the r and theta limits. R is equal to 0 to a and theta is equal to 0 to pi by 2. The first function is y in the given question and the y value is r sin theta. And again here root of x square plus y square is there here. Then x square plus y square is equal to r square in general. X square plus y square is equal to r square. Then the value of x square plus y square is equal to root of r square, that is r only. Now here I am substituting that r. And again in the question dx dy is there. Okay. So we know that dx dy value is r dr d theta. R dr d theta. So at finally the term is integration 0 to pi by 2 r is equal to 0 to a. So r cubed sin theta and again dr d theta. So one thing you have to observe here, students, the both limits r and theta limits are as a constants, then we may do the integration with respect to r at first, or we may do the integration with respect to theta, because both limits are in terms of constants only. Okay, so at first I am doing integration with respect to r here, or I am doing here integration theta is equal to 0 to pi by 2 sin theta common, r cubed integration is r power 4 by 4 within the limits 0 to a, and next is d theta. Okay, and integration theta is equal to 0 to pi by 2 and sin theta, substituting the upper limit a power 4 by 4 into and d theta. Okay, because the lower limit is 0 here, then making a power 4 by 4 is constant, then theta is equal to 0 to pi by 2, then sin theta and into d theta. So next doing integration with respect to theta here, then a power 4 by 4, then integral of sin is cos theta 0 to pi by 2, then writing minus here, minus a power 4 by 4, then cos pi by 2 minus upper limit minus lower limit, then minus a power 4 by 4, then cos 90 value is 0 and minus cos 0 is 1, then final answer is a power 4 by 4.